Okay, and we just finished off on doing f of x plus 3. And this is what we should have had, is negative 3x squared minus 16x minus 21. Okay, let's flip this over, and we are going to do a little bit more complicated one. F of x plus h minus f of x, all of that divided by h. And of course, since we're dividing by h, it cannot equal 0. And we've defined f of x to be negative 3x squared plus 2x. So if I were to write this out, right now I'm just going to write out the f of x plus h. Let's zoom in a little so you can see this. So negative 3, and wherever there's an x, I'm putting the x plus h squared plus 2 times x plus, bad lead, plus h. So this right here is f of x plus h. Now I need to subtract, so big parentheses here, negative 3x squared plus 2x, because that represents f of x right there. This part right here is f of x plus h. And all of that's going to be divided by h. Okay, let's see if we can simplify this, because I'm sure we can. Okay, I've got to multiply out the x plus h times x plus h, so I still have the negative 3 out in front. And when I do box or FOIL, I'm going to have, gosh, let's switch pencils here. I'm going to have x squared plus 2xh plus h squared plus, and let me go ahead and distribute this 2 right now, 2x plus 2h minus, I'm subtracting both, so minus a minus is a positive 3x squared, minus a positive is subtraction. All of this divided by h. Okay, let's do a little bit more distribution here with the negative 3. So I've got negative 3x squared minus 6xh minus 3h squared. Oops, and I've started to run into this guy. Plus 2x plus 2h plus 3x squared minus 2x. All of this is over h. Okay, so we've got all these pieces now. Notice there's no more parentheses because I've distributed everything that had to be distributed. So now I just need to combine my like terms. So for like terms, I've got 3x squared, a negative 3x squared, positive 3x squared. Those are going to cancel with each other. I've got, let's see what's next, a negative 6xh. I don't have any others, so that's going to remain. Okay, and I'm just crossing them off as I use them. Okay, I've also got a h squared, no other h squared, so that's going to stay here. And I've got 2x and a 2x, positive 2x, negative 2x, those cancel, plus a 2h right here. Okay, and all of this still divided by h. Well, you may notice all of these have an h in them. So let's go ahead and factor that h out, because then I'll be able to reduce it with what's on the bottom. So if I divide this first term by h, I get a negative 6x. If I divide the second term by h, I get a negative 3h. And the last term divided by h leaves just a 2. All of that is over h. Okay, now that I've got two things multiplied together, I can go ahead and cancel the h with the h. And I'm left with a negative 6x minus 3h plus 2. That is what's called the difference quotient of x plus h. And again, you might just want to write a note. This may be referenced in calculus. So this is the difference quotient. Anytime you want to see the difference in a function, when you add a certain amount, you do f of x plus h minus f of x divided by h. Okay, let's take a look and figure out the domains of these guys. The first thing we're going to have to do when we look at the domains is factor them. So we've got an x plus 4. In the denominator, I need two things that multiply to negative 3 but add to negative 2. So that's going to be a negative 3 and a positive 1. And again, I can go straight to the factored form because the coefficient of x squared is a 1. Okay, once I've got this, the thing that's going to limit my domain is that I can never divide by 0. So anything that would make either factor equal to 0 cannot be in my domain. So in this case, it's going to be the set of all x's such that x does not equal 3, because that would cause that to be 0, and x cannot equal a negative 1. Again, anything that would make either factor 0 is not acceptable in the domain, because we can never divide by 0. Okay, again, let's take a look at factoring this guy. This factors into x plus 3 times x minus 3. And is there anything that we can't multiply together? And there's not. So my domain is not limited whatsoever for this function. So it's going to be the set of all x's such that x is an element of all real numbers. All things go for that one. And finally, let's take a look at C. Okay, things that we limit in square roots. The only thing we cannot take a square root of is something that's negative. So I need what's under my square root to be greater than or equal to 0. So 3 minus 2x has to be greater than or equal to 0. So it's going to be all the x's that make this true will be acceptable in the domain. So first thing I'm going to do, let's go ahead and subtract the 3. So I've got negative 2x is greater than or equal to negative 3. Divide by negative 2. And remember, when you divide by a negative, your inequality flips or reverses. So now I have x is less than or equal to 3 halves. So this is what my restriction is for the domain. So my domain is a set of all x's such that x is less than or equal to 3 halves. And if you wanted to put 1.5, that's perfectly okay. Okay, last one. Oh, look at this. We've got a square root and we're dividing. So I've got two things I've got to look out for. I've got to see what makes this positive, or what makes it greater than or equal to 0, and what makes the denominator not equal to 0. So two different things going on. So for the denominator, x cannot equal a positive 5, because that would make the denominator 0. For what's in the numerator, my square root, because I can't take a square root of negatives, I've got to restrict the domain to not include any x values that would make this negative. So just like we did here, I'm going to take what's under the square root symbol and say that's got to be greater than or equal to 0. If I subtract 12 from both sides, I get 3x is greater than or equal to negative 12. And notice the inequality does not reverse because I did not divide by a negative or multiply by a negative. I'm dividing by 3, so again, that will not reverse. So here I get x must be greater than or equal to negative 4. So putting these two restrictions together gives me a domain of set of all x's such that x cannot equal 5, because again, that would make the denominator 0, and x must be greater than or equal to negative 4. So both conditions must be met for x to be an element, or for a number to be an element of your domain.